Thank you for joining this lesson. We're going to talk about area by integration. We are told that the diagram below shows a straight line 2x plus y equals to 8, intersecting the curve y equals to 2x squared minus 4x plus 4 at the points P and Q. Just as shown on the diagram, you can see the points P and Q where the line intersects the curve. Then part A is talking about find the coordinates of P and Q, the points of intersection of the curve and the line. When two functions are intersecting, we just solve the equations of the functions simultaneously. From the curve, the value of y equals to 2x squared minus 4x plus 4. From the line, y equals to, we can re-express this line such that we start with y being equal to 8 minus 2x. So if they are intersecting at a point, then we will equate the two sides now. At the point of intersection, 2x squared minus 4x plus 4 is equal to 8 minus 2x. Can have 2x squared minus 2x, because negative 4 plus 2x when we're grouping like terms will be negative 2. Then we have positive 4 minus 8, which makes it a negative 4 equals to 0. 2 is common, so we can have x squared minus x minus 2 is equivalent to 0. Then we solve the quadratic equation whereby the product of a times c, which is the 1 times negative 2 is negative 2, and the sum of b negative 1. Remember, I'm using the factorization method, so I will need negative 2 and positive 1 so that I get a product of negative 2 and the sum of negative 1. Now we can talk about factorizing x squared. Then we replace negative x by negative 2x and x. Then we have minus 2 equals to 0. We factorize the common factors in every two terms. X, we remain with x minus 2. Then positive 1 can only be factorized, so that we remain with x minus 2 equals to 0. So we pick the common factor, x minus 2 is equivalent to 0, and also x plus 1 is equivalent to 0. So with this, we can talk about x being equal to 2 and x being equal to negative 1. Therefore, according to the drawing, x will be 2 at Q. This is x equals to 2. Then x equals to negative 1 at P. Therefore, at P, x equals to negative 1. Now I want us to get the values of the coordinates. Because the value of y can be obtained by replacing in any of the equations, we can replace in the second equation. Using 2, the value of y is going to become 10. Using 2, the value of y is going to become, let me follow keenly. We will have 8 minus 2 multiplied by 2. That will be 8 minus 4. So I'm getting a 4. Then at negative 1, x equals to negative 1, the value of y is going to become 8 minus 2 into negative 1. So it becomes 8 minus, it becomes a positive now, 8 into negative 2 into negative 1. So it will be 8 plus 2, making it a 10. Therefore, the coordinates of P will be negative 1, 10. The coordinates of Q will be 2, 4. So those are the coordinates of intersection for the curve and the line. Calculate the area of the shaded region. For us to calculate the area of the shaded region, we have to get the whole area bounded by the line and the ordinates negative 1 and 2. That makes it a trapezium. Therefore, area of a trapezium, whereby the first height is from 0 all the way to the value of y at p, which is 10, and the other height is from 0 to 4. The height is 4. Then now the area between, or the line between them from -1 all the way to 2, that is the parallel line, that is the perpendicular line between the two parallel sides now, is +3, because from -1 all the way to 2 we have a 3. Therefore, we are going to say that for the trapezium, area is going to be half. Sorry for this. Area is going to be half multiplied by the sum of the two parallel lines, whereby we have a 10 and a 4, multiplied by the perpendicular distance between them, which is a 3. Therefore, we're going to have this is 14 divided by 2, which is 7. So by 3, I will get 21 square units. 21 square units. That is the area of the trapezium. Now, area between the curve and the x-axis. Let me show you the area now I'm talking about using a different color. I'm now talking about this area now. The area below the curve, the x-axis, and the lines x equals to 1 all the way to x equals to 2. The area bounded there will only be calculated by the integration now from -1 all the way to 2 for the function 2x squared minus 4 plus 4 plus 4 then we're going to have a plus 4 with respect to x. When we integrate this, we're going to have the power of 2 will increase to 3, then it divides here such that we have 2/3, but x now becomes power 3 minus the power of x now goes to power 2, and the 2 divides such that now it becomes 2x squared plus 4x is introduced, then plus a constant. This is from -1 to 2. So now we can substitute in the function such that we have 2/3. We start with 2 power 3 minus 2 into 2 squared plus 4 into 2 plus a c. Then we will be subtracting. When we substitute 2/3 and x is -1 power 3 minus 2 into -1 squared plus 4 into -1 plus a constant c. Therefore, in the first case, when you use a +2, we're going to get 5 1/3 plus a constant minus -6 and 2/3 plus a constant. So at this point now, we can talk about 5 1/3 plus a constant, then positive now, 6 and 2/3 minus c. So the constants of integration will cancel one another, and we're going to end up with 12 units. 12 square units. 12 square units. Now we have 12 square units for the area between the curve and the x-axis, and area of the whole trapezium is 21 units. So the shaded area now is going to be 21 minus 12, giving us 9 square units. 9 square units. After this, we can talk about now the last part. See, find the coordinates of the stationary points on the curve y equals to 2x minus 4x plus 4. Remember, this is a quadratic curve, so it has only one turning point. And we usually say at the turning point, the gradient of a curve is usually 0. So the first thing we do here is to get the gradient function of the curve, dy dx, to differentiate y with respect to x. When we are differentiating, this power is dropped such that 2 will be multiplied by 2 to give us 4. X, the power reduces by 1. then minus. The power is 1. So when you drop 1, negative 4 will remain negative 4. And the power now becomes 0. So x power 0 becomes 1. So we just get a 4. Now, this is the gradient function. So the value of the gradient at the turning point will be 0. So x at that point is going to be 4x equals to 4, and the value of x becomes 1. If the value of x is 1, then for us to get the coordinates of the stationary points, we have to also get the y, such that we need 2 into 1 squared minus 4 into 1 plus 4. Therefore, 2 minus 4 plus 4 will become 2. So at the turning point, the coordinate will be 1, 2.